The structure and operating principle of the water-powered observatory. The water-powered Armillary and celestial tower is driven by the force of flowing water. Its main functions include observing celestial objects, representing celestial movement, and timekeeping. These functions are housed in 3 separate stories. The topmost Armillary sphere is for observing the path of celestial objects. Its most significant improvement from its predecessors is its ability to automatically track the targeted celestial object. The 118-centimeter celestial globe is on the middle story, provides a cross-reference point to the data collected from the Armillary sphere. The bottom story houses an intricate water clock, covered by a facade that imitates a pagoda. Water power engine. The water power engine system of the water-powered Armillary and celestial tower is comprised of a manual wheel, an intermediate reservoir, a lower reservoir, and the upper and lower norias. The new design for an Armillary and globe has included the procedure to start the clock tower. First, the lower reservoir is filled with water. Next, the manual wheel is turned manually to initiate simultaneous rotation of both the upper and lower norias. This way, the norias should be set in motion so that water can be transported from the lower reservoir to the intermediate reservoir. The 8 cylinders on the lower noria should properly transport water to the intermediate reservoir, which, simultaneously, the 16 cylinders on the upper noria should properly pour the water into the upper flume. An engine system powered by the force of water. The water flows through the upper flume into the upper reservoir. A siphon connecting the upper reservoir and the constant level tank should regulate the water's outflow to a constant rate. As it fills into the water receiving scoop set along the edge of the driving wheel, this complex mechanism ensures a steady flow of energy, which is crucial for the clock tower to function as a scientific device. The rotating axle. The driving wheel is the transmission system of the clock tower, with 36 water-receiving scoops on the tips of the wheel spokes to rotate the wheel by the weight of the water they carry. Every 25 seconds, enough water should be filled, so the scoop outweighs the checking fork located below, and drags the driving wheel downwards. The escapement mechanism is made up with 3 sets of levers, which 2 of the 3 sets are placed under the water-receiving scoop. One is the lower balancing lever, with a checking fork on one end and the lower weight on the other. The other is a trip lever connected to the upper balancing lever. The checking fork is a special lever designed to keep the water-receiving scoop in place. As the water fills into the scoop, it gradually gains more weight. When the scoop's total weight outweighs the lower weight, the checking fork will be tipped downwards, allowing the scoop to drop by gravity, thus rotates the driving wheel, and simultaneously activates the trip lever that connects to the upper balancing lever through the connecting rod. The upper balancing lever is one of the 3 levers within the escapement mechanism. As the trip lever is being pressed downwards by the water-receiving scoop, the latch mechanism on the left side of the upper balancing lever is simultaneously released by the connecting rod to halt the driving wheel's rotation. When the upper stop is released, the driving wheel is able to rotate, as it's being pulled downwards by the water-receiving scoop's weight, which would also empty the water in the lowest scoop into the sump. When the driving wheel rotates, a rachet is lifted by a pin at the end of the wheel's spoke, while the next scoop should arrive right above the checking fork to be filled up with water. The upper stop should relapse back to its original position to retain the driving wheel. To counter the recoil caused by the scoop pin hitting the upper stop, the upper lock would drop back to its original position to ensure that the driving wheel would rotate constantly forward. This finely controlled rotation is known as an escapement cycle. As the next water-receiving scoop fills up with enough water to tip the stopping tongue, and triggers the sequence of escapement mechanics, this cycle continues in a seamless and virtually endless fashion, which allows the driving wheel to rotate at a constant interval. Transmission system. The water-powered Armillary and Celestial Tower is powered by the force of water, which turns the driving wheel and brings life to the entire tower. The vertical transmission shaft is the backbone of the tower's transmission system. It is comprised by 3 gears placed along the shaft: the lower wheel, the middle wheel, and the upper wheel. When the driving wheel rotates, a gear train system would also bring the lower wheel into motion to rotate the entire vertical transmission shaft. Meanwhile, the middle wheel would rotate the day and night timekeeping wheels through another gear train system, so that the celestial globe on the middle story will also start to rotate. Meanwhile, the upper wheel of the vertical transmission shaft would set the armillary sphere in motion through similar mechanism.